most important one. Okay. Yeah, so screen is visible. Respond anyone.
Yes, sir.
Yes, sir.
Okay, so now we are discussing about the Ruby laser. Yesterday we discussed little introduction about the Ruby laser. So first of all, this is the Ruby laser is the first laser. So Ruby laser is a first laser. So this was prepared in 1960. So who is prepared demonstrated this? So T.H. Myman. So T.H. Myman. Okay, so this is the solid state laser, and it is 3-level laser. This is the just introduction about the Ruby laser. Okay, now coming to the what is the active medium in that Ruby laser. So this Ruby rod is prepared while by using Al2O3 and Cr2O3. Okay, so alumina and chromium oxide. So by using these two, so we can prepare the Ruby, right? But what is the active medium means? Here Cr3 plus ions are the active medium. Okay, Cr3 plus ions are the active medium in this Ruby laser, and some of the aluminum atoms are replaced by 0.05% of chromium atoms. So how much we are doping here chromium means just 0.05%. Okay, lasing action takes place in chromium energy levels. Okay, that's why we are calling here what is the active medium. So chromium 3 plus ions are the active medium because lasing action is takes place so in the chromium ions only, chromium energy levels only. Okay, next what is the energy source? So to getting the lasing action, that means to getting the lasing action, population inversion is required. Population inversion is required. How to achieve the population inversion? So how to achieve the population inversion means here optical pumping we are using here. So for producing the optical energy, so we will use xenon flash lamp will use here. Okay, that is the energy source. Now coming to the construction of Ruby laser. See here, so this is this diagram. So this diagram seems to be how to construct the Ruby laser here. So inside Ruby rod is a that Ruby rod is so mixture of Al2O3 and Cr2O3, mixture of Al2O3 and Cr2O3. So how much percentage of Cr2O3 doping we here mean just 0.05% of chromium oxide we are doping. Okay, so that chromium, if because of doping of the chromium oxide, what happened? So that alumina 0.05% of aluminum, so replaced by chromium 3 plus, ions. So that's why, so these chromium, that 0.05% chromium ions will act as a active medium, active centers, will act as a active centers, and aluminum and oxygen atoms are inert. Okay, so inert means those are not involved in a lasing action. Lasing action. Okay, so here chromium ions have absorption bands in the blue and green regions. I will explain you how it will be. So absorption band means so it will minimum energy required to get absorption. Okay, so here, so this is the absorption band here. So this is the E3 band and this is the E4 band of the chromium atom. So if you, this is the ground state, if you supply minimum energy, so that means how much minimum energy we have to supply. So that means whatever the green energy, so that much energy if you supply, those atoms will goes to the so E3 level. If you supply the blue, so what is the frequency of blue? 6.06. Green 5.54 it will be there. Okay, so that means so depends on the their frequency, their energy also depends on so like that. What happen if you supply energy? So if you supply so that much of energy, So energy, what happened here? So those will goes to the higher energy states. These ground state energy atoms will go to the higher energy state. So here, what is the minimum energy is required means? So here minimum energy is required. So this green energy, and here so another energy is required, blue energy. So other energy is not absorbed. Only it absorbs the energy of the green and it absorbs the energy of the blue. Okay, energy of the blue means, so what is the blue energy? Blue energy means, what is the frequency of blue? 6.06 into 10 to the power of 14 hertz. Okay, so that is the frequency of blue. So h into, so that value, it gives the energy of the blue. So h is the Planck's constant into frequency of the that color, frequency of the color. So that will give the energy. Okay, that only that energy it will be absorbed. Remaining energy is not useful. So if you whatever this you will supply the remaining energy, that is not useful. Only your useful energies are two useful energies. One is the green frequency corresponding energy, and another one is the blue frequency corresponding energy. Okay, so only these two are absorbed. See here. So that's why, so chromium absorbs the blue and green lights. Chromium absorbs the blue and green lights only. Green lights only. It will not absorb any other light. Okay, because of that absorption, what happened? So those ground state atoms will goes to the excited state. If they absorb green means they will goes to the E3 level. If they absorb blue means those will goes to the E4 energy level. Okay, understood? So depends on the absorption, depends on the absorption of the chromium atom. So those will goes to the different energy levels. If they absorb green energy means, so green light, if they absorb the green light means they will goes to the E2 energy state. If they absorb blue light means they will goes to the E4 energy state. So E3 and E4 energy states. Understood? Now coming to the ruby rod is taken in the form of cylindrical rod of 4 centimeter. So this rod length is just 4 centimeter, 4 centimeter in length and 1 centimeter in diameter. So diameter is here 1 centimeter, length is 4 centimeter. And one more thing here, so we need optical resonator. We need optical resonator to getting the lasing action. So lasing action, that's why. So what we are doing, so its ends, ruby rod ends. So these are the ends now. So one is the rear end, another one is the front end. Okay, so these ends are polished. These ends are polished. Polished at the faces, are exactly parallel and are also perpendicular to the axis of the rod. Okay, so these are the two polished surfaces. So one is the rear surface, another one is the front surface. These two are exactly parallel and perpendicular to the axis of the rod. This surface, yes. Okay. Yeah, so screen is visible now. See here, so this is the front end and rear end. These two are yes sir, these two are parallel with each other and so perpendicular to the axis of the rod. So these two ends are the parallel with each other as well as perpendicular to the axis of the rod. That means, so this rod should be straight line. This rod should be straight line. If rod will be any bending will be there means those edges are not parallel. If any bends, so if any bends will be there on that rod means, so those plates are those edges are not parallel. Those edges are not parallel. Okay, that's why this rod should be straight line. This rod should be straight line. Okay, so and length of the rod is 4 centimeter and width and diameter is 1 centimeter. Diameter is 1 centimeter. Okay, now coming to the end faces of ruby rod are silvered so that they form the optical resonator. So that means these end faces. So rarer phases and front phase. So rarer phases are fully that means silvered, fully silvered. So and another front face is partially silvered. Front face is partially silvered. So because of
That is
fully
great.
silvered, what happened? Yes. So because of fully silvered, so what happened? This will be totally reflected. So it light is not transmitted from this surface, from this end. Okay. So because of partial silver coating, because of partially silver coating, what happened here? So just so it will be 95% reflect back, only 5% it will be transmit. 5% only transmit. Whenever laser beam getting the sufficient intensity of light, then it will be transmitted out. Then it will be transmitted out. Now next point, the laser rod is surrounded by a helical photographic flash lamp filled with xenon. Okay. Whenever activated by the power supply, the lamp produces flashes of white light. See here. So this, so xenon flash lamp is surrounded by the that this is the helical xenon flash lamp. Okay. So this helical xenon flash lamp, so that is inside it was a ruby rod. Inside it was ruby rod will be there. So if you will take this helical flash
Hello.
lamp, inside, yes, inside there is a argon gas is
Can you
there
repeat the point
inside.
again, sir?
Which point? This
Point.
helical shape. Okay.
Yes, sir.
So
That's
yeah,
right.
okay, I will explain you. So here ruby rod is there. So that ruby rod is surrounded by helical uh, flash lamp, helical photographic flash lamp. Okay. So this laser rod, ruby rod is surrounded by helical photographic flash lamp. Okay, so in that flash lamp, there is a xenon gas will be there. In that flash lamp, there is a xenon flash lamp will be there. So when we will supply the power here, so that xenon atoms will goes to the excited state. Xenon atoms will goes to the excited state and again comes to the, after completion of their lifetime, they will come to the ground state. While coming to the ground state, it will emit the white light. Understood? So why here white light is coming? Why here? So this is the xenon flash lamp. In that xenon flash lamp, xenon gas will be there inside. So xenon gas will be there inside. When we will supply the power supply, when we will give the power supply here, so that xenon atoms will goes to the excited state. So after completion of their lifetime, they will comes to the ground state. That's why what happened? It will produces the white light. That xenon flash lamp will produces the white light. So that white light absorbed by the this ruby rod. That white light absorbed by the ruby rod. Already I said that. So only it is used the blue and green light. Remaining light is it will be so white light contains so all colors. So Vibzi are violet, blue, indigo. So these are all colors. 7 colors will be there. But in that 7 colors, so this ruby dot absorbs only particularly 2 colors. So blue and green, because chromium having so absorption bands particularly. So these energy levels only. So these depends on their energy levels. So that absorption will be depends on. Okay. So that's why in that white light, so ruby rod absorbs only two colors, because here chromium absorbs so blue and green colors only. Remaining colors are, so it will be not useful. Remaining colors are not useful. See here. So we will discuss now working. Okay, so this is about the construction of the ruby rod. Now we will discuss about the working of the ruby rod. Okay, so the energy level of chromium 3 plus ions in the crystal lattice are so shown in the figure. So here, so energy levels of the, so this chromium atom is given. Okay, because why we are discussing only chromium? Only chromium means so lasing action is takes place in chromium. That means chromium is active medium. Chromium is active medium. Aluminum and oxygen are the inactive. Okay. So Now we are taking here, so chromium absorbs the blue and green regions. So if you absorb the blue light means, so those ground state atoms will goes to the E3 level. So if chromium absorbs the blue region, if you chromium absorbs the green region means, so ground state atoms will goes to the E3. If chromium absorbs the blue region means, ground state atom will goes to the E4, E4 energy level, E4 energy level. Okay, so this is the absorption bands. E3 and E4 are the absorption bands, and there is a one more state is there, that is the E2 state, that is the metastable state, that is the metastable state. Okay, so metastable state, that is the E2 level, and here lifetime of E2 state is very greater than the so E3 and E4 states. Okay, approximately, so more than 1000 times that energy lifetime of the E2 level, lifetime of the E2 level is more than 1000 times of the E2 and E3 and E4 levels. This E2 energy lifetime is E2 level lifetime is so greater than the E3 and E4. That's why this will act as a E2 level will act as a metastable state. E2 level will act as a metastable state. Okay, now what happened here? Okay, when the xenon flash lamp is switched on, the discharge generates and intense burst of the white light lasing for a few milliseconds. Okay, because of if you whenever switch it on, what happened? So white light is coming out from the xenon flash lamp. The chromium ions are excited to the energy bands E3 and E4 by green and blue components of white light. So this chromium absorbs the blue and green component of the white light. So that's why what happened, those atoms will goes to the so excited state, so excited state to E3 and E4 level. Okay, and see here, so that chromium ions undergo non-radiative transition from these energy level to E2 energy level. So this is the E2 energy level. Here from E3 to E4, so from E4 to E2 as well as E3 to E2, here non-radiative transition will be takes place. Non-radiative transition will be takes place. Okay, so what is the reason for non-radiative transition? I said that there is some selection rules is there for radiative transition. Okay, so those selection rules are not followed here. Already in semiconducting lasers, I said that there is a while explaining the LED, I said that there is a what is that direct band gap, indirect band gap. I said that. Okay, if direct band gap will be there, then only light will be emitted through that transition, so that means, so here at that case selection rule is followed. So in that case selection rules are not followed. That's why, so here radiative transition not occur. So that is E4 to E2 and E3 to E2. Okay, that's why here transition will be takes place. That is not radiative transition. That is a non-radiative transition. In this transition, light does not emit. So just phonons are emits. Phonons are nothing but either sound or heat. Okay. So in this, so and one more thing here, E2 level is metastable state. See here, that metastable state E2 has lifetime approximately 1000 times more than the lifetime of E3 level. Similarly, E4 level also. Okay, so this lifetime of E2 is very greater than the so E4 and E3. So that's why what happened here. So more electrons will stay. And population inversion occur between the E2 and E1 level. Population inversion occur between the E2 and E1 level. See here. So population inversion is established between the E2 and E1 levels. Why? What is the reason? Means lifetime of E2 level is high compared to the E4 and E3 level. So those E4 atoms will come to the E2 level as well as E3 atoms comes to the E2 level. That's why here there is more number of electrons will be accumulated at the E2 level, accumulated at the E2 level. Okay, so that's why population inversion occur in between the E2 and E1 level, E2 and E1 level. Okay, now coming to the, because of this energy, so here transition occur in between the E2 and E1 level. So this transition is depends on the their energy difference, E2 minus E1. Their energy difference is equal to the red energy. So that's why here emitted energy is red color. Emitted energy is red color. Okay, so here emitted energy is two different wavelengths. One is the 694.3 nanometer, another one is the 692.7 nanometer. So these all both are red color only. So but wavelength is little different, because so this energy level, E2 energy level, is not exactly fixed to the one particular energy. So it is a band of energy. It is a band of energy. Okay, that means band of energy means there is a range of energy values will be there. Okay, so particularly there is a range of energy values will be there. So that's why, so here there are two different red colors will be emitted. So one is the wavelength of 694.3 nanometer, another one is the 692.7 nanometer. Okay, so red color will be emitted here. So in terms of angstroms, 6943 angstroms, 6943 angstroms. Okay, now coming to the, yeah, red photons of wavelength 6943 angstroms traveling along the axis of the ruby rod are repeatedly reflected at the end of mirror, and the light amplification takes place. The laser emission occur in the visible region at the wavelength of 6943 angstrom. See here, uh, so here we are, that means light is emitting. Light is emitting in the ruby rod. So that that red light is traveling along the axis of ruby rod. That red light is traveling along the axis of ruby rod, and so at the edges of the ruby rod, there are a optical resonators. Optical resonators are there. So because of that optical resonator, that red light again, so reflecting back and front and back again and again. So that red light reflecting front and back again and again. So that red light, so already yeah, so this emitted red light triggers the this E2 electrons, so E2 energy state electrons. Because of that triggering, what happened, all electrons will comes to the ground state. Okay, so now, so these electron, so while coming to the electron, what happened, photon will be generated. These photons again reflect back again, triggers the these excited electrons, again triggers the these excited electrons. So now what happened, again and again, so their intensity will be increases, amplification will be takes place whenever these will get the particular intensity. So those will come out from the ruby rod, that light will be come out from the ruby rod. Okay, so yeah, so and one more thing, why there is a one disadvantage is there, that output of ruby laser is not a continuous wave, but it occurs in the form of pulses. Okay, so this is about the working of ruby rod. Now coming to the applications. Okay, so what are the applications of the ruby laser? We will discuss now. So ruby laser is used in distance measurement using pulse echo technique. So in pulse echo technique, we will use the ruby laser. Okay, so what is the use of pulse echo technique? Means it measure the distance. So measure the distance between the two objects. Otherwise, suppose depth of the sea. So if you want to measure the depth of the sea, so we can use this ruby laser. Okay, otherwise distance between the two hills. Okay, so we can use, otherwise distance between the two objects, so we can use. Okay, ruby laser is used to create halograms of large objects such as aircraft. Okay, if you want to create the halograms of the large objects, we can use the ruby laser also. uh, one more. Next one is it is used in atmospheric ranging, scattering studies, and uh, LI, so lidar measurements. Okay, so these are used to atmospheric ranging, scattering studies, and lidar measurements. So and it also used in uh, trimming resistors and integrated circuits. Suppose if you want to make the resize of resistors and ICs, integrated chips. Okay, so we can use the this ruby rod, ruby laser. So ruby laser were used mainly in research. One of the main industrial uses drilling holes through diamond. Okay, so for drilling the holes in diamond, we can use the ruby rod. So and it also used in military as a target designators and the range finders. So for finding the range of the other opposite soldiers, we will use the this ruby rod and target designator. If you want to fix the target, so we will use the this as a designator for target designator. And this also used in research applications such as plasma production and fluorescence spectroscopy. So plasma production means this is the fourth state of the, that means actually we have three states, so gas state, solid state, and liquid state. So another state is plasma state. If you want to produce the plasma state, we can use the ruby laser. And fluorescence also we can, if you want to get the fluorescence, we can use the uh, so this is the ruby laser. And ruby laser were used in extensively in tattoo and hair removal. So for removing the tattoo and hair removal, unwanted hairs removal, so we can use the ruby lasers. Okay, so this is about the some applications of ruby laser. Now there are some drawbacks also there in case of ruby laser. As a ruby laser is a three-level laser. Three-level, so pumping scheme, it generally requires very high pumping powers. Very high pumping powers. Okay, so if you will use four-level laser means compared to three-level lasers, so four-level laser require very less energy, Okay, so now, so if you will take only two-level laser means that is it is required very huge amount of energy for two-level laser. So if you increase the number of levels, so that energy will be, whatever that energy will be used is reduces. Okay, now next one is the efficiency is very less. Efficiency is very less. So because why efficiency is very less means we are supplying white light here. In that white light only it absorbs only two colors. It absorbs only green and blue color. Remaining all color, remaining, so total 7 colors will be there in white light. So remaining all 5 colors will be wasted. So wasted. Okay, so only it absorbs the two colors. So that's why its efficiency is very less. Next one is the laser output is not continuous. It is a pulsed mode. So if you want continuous laser, so it is not useful. It is not useful. This is pulsed laser. Pulsed laser means so that laser will come at a 1 second and it stops some seconds and again it will come. So like that. So it is a pulsed laser. So these are the main drawbacks of the ruby laser. Okay. So once again I will explain you so construction and working. Okay, so simply, so what this is the introduction means whenever it will be, so this is the first laser you can write. So it will be so demonstrated in 1960 so by th Myman. So this is, and it is a solid state laser and three level laser. Okay, that is the just introduction about the ruby laser. And you have to write what is the active medium here. Active medium, so generally we are using here ruby rod. Ruby rod consists of Al2O3 and Cr2O3, but so active medium is only chromium 3 plus ions are the active medium. Next, so what is the percentage, chromium percentage? Just 0.05% of chromium atoms is replaced by the aluminum atoms. Okay, some of the aluminum atoms are replaced by just 0.05% chromium atoms. Okay, so next, that means how much percentage of chromium we are doping? 0.05% of chromium Cr2O3 we are doping here. Okay, and energy source. Energy source is here xenon flash lamp. Xenon flash lamp because so this pumping is optical pumping. Optical pumping. So for optical pumping, we have to supply the optical source. So by using a xenon flash lamp, we will supply the optical source to the ruby rod. Okay, so this is about the introduction. Now coming to the construction. So in that construction, so basically we will take Al2O3 crystal containing 0.05% of chromium atoms. Okay, so this is ruby rod we are taking. In that ruby rod, alumina and so chromium oxide. This is the mixing of alumina and chromium oxide. Okay, so in that ruby rod, so Cr3 plus ions are active centers. Active centers are nothing but active medium. So remaining aluminum and oxygen. Aluminum and oxygen are the inert. Okay, so chromium atoms absorbs the light energy. So absorbs the light energy. Which energy it absorbs? So just blue and green regions energy it absorbs. So it absorbs just blue color and green color. Remaining colors are not absorbed. Okay. So and ruby rod is taken. So and its diameter is given. It's 4 centimeter length and 1 centimeter is diameter. Okay. And so its faces. These faces are so polished, fully polished. Okay, so polished surfaces, and those are coated with silver coated. So one side it is fully coated, another side it is partially silver coated. Okay, so one side it totally reflected, only another side 95% reflected the light, only just 5% transmit. Okay, and now so last one is the so this xenon flash lamp. So whenever we will give the power supply to this xenon flash lamp, what happened? So it will emit the white light. It will emit the white light. What is the reason to emit the white light means? So whenever we will give the power supply, that xenon atom will goes to the excited state. So after few seconds, it will comes to the ground state. While coming to the ground state, it will emit the white light. Okay, this is about the construction. Now working. So working here, so this is the energy levels of the chromium atoms. There are 4 energy levels are there: E4, E3, E2 and E1. Okay, so this E4, E3, E2, these are involved in a lasing action. That's why we will call it as this is 3 level laser system. So whenever light is absorbed, that chromium absorbs the light. So what happened? Those atoms will goes to the excited state E3 and E4 levels. E3 and E4 levels. When it absorbs the green light, it will goes to the E3 level. When it absorbs the blue color, it will goes to the E4 level. Okay, and so in between E4 level and E2 level, there is a transition will be there. The transition is non-radiative transition, and similarly E3 and E3 and E2 level, there is a transition will be there, that also non-radiative transition. So because of that non-radiative transition, there is no light will be emitted. Okay, so because there are selection rules are not followed there. Okay, now there is a transition occur in between E2 and E1 level. So because of the transition, what happened here? Light will be emitted. Light will be emitted. So this light is resonated. That means amplified by using resonator. So what is the resonators here? So polished surfaces are the resonate will act as a resonators. Okay. So because of that amplification, what happened? High intensity laser beam will come out. So what is the emitted laser here? A red light will be emitted. Red light will be emitted. What is the absorbing portions here? So green and blue colors are absorbed. So emitted color is red color. Emitted color is red color. Okay. So this is about the working of the ruby laser. So application, you know that. Okay, and drawbacks. So read ones. So mainly 3 drawbacks are there. First one is the this is a 3-level laser system. That's why here very high amount of energy is required to pump the electrons. Okay, so pump the electrons from the ground state to excited state. Okay, so that is the one drawback. Second drawback is efficiency is very less. Efficiency is very less because it absorbs only green and blue color. Remaining colors are wasted. So that's why. So that efficiency is very less. So efficiency, what is the definition of efficiency? So output by input. Input we are giving so white color. So totally 5 colors energy we are giving, but only 2 colors are emitted here. two colors are sorry, only one color is, so two colors are absorbing here, two colors are absorbing here, remaining colors are not absorbed. That means so that much of energy is wasting. Okay, and now the output is not continuous, the laser output is not continuous. So whenever we require so continuous laser, so this is not useful, ruby laser is not useful. So that's these are the main drawbacks of the ruby laser. So what is the time now? Yeah, so 3 minutes will be there. Is there any doubts on that ruby laser? So this is most important one, ruby laser and helium neon laser. So these all are so very important. If you have any doubts, you can ask. Okay, so tomorrow we'll discuss about the helium laser. Okay, first of all, I will take the attendance. So if you have any doubts, means you can ask here. Any doubts, Sunaya?
No, sir.
No, sir.
Okay. Okay. Yeah, I am taking the attendance. Then after you can leave. Yes, you can leave from the session.